Hey guys, how are you doing? How's everything? And welcome to part 2 in forces. We have already elaborated in part 1 about the definition of forces and what are the effects of forces, what can forces actually do, right? And we have spoken about friction, okay, as a type of contact forces, as it happens between the object when they come in contact with each other, right? We have explained that friction has some types, and first of them was the friction between solids. Second is our part today is about the air resistance and water resistance. Now, what makes the air resistance a friction force? Okay, now whenever you are moving in a certain direction, okay, for example, you are driving a car, you find that your body and the car as well is coming in contact with the air particles, right? And because these air particles are rubbing against the body of the car and your body as well, so we call it a friction force, and it is a friction force. Okay, so air resistance is a second type of friction, okay, because it happens between the air particles and the moving object in the air. And watch out, air resistance only happens to particles or to bodies that are moving, okay, in a certain direction. Similarly, water resistance. Now imagine that you are diving or you're swimming. Okay, so now your body is moving in a certain direction, and in the opposite direction, the water particles are rubbing against your body. Okay, so water resistance is another type of friction, and it happens between your body and the water particles. Right, now let's figure out what makes friction more or less. And these rules are applied on friction between solids, water resistance, and air resistance as well, because all of them are types of friction. So the first factor that will make the friction more or less, bigger or smaller, is the shape of the object. And I have already mentioned in the classroom, if you have a big car or an SUV car and you have a sedan car, okay, which one of them has more contact with air particles? Okay, so definitely the one that has a bigger shape, okay, or a bigger size, right? Because the bigger size of the object has more particles that come in contact with it, right? So again, object with a streamlined shape will have a less friction. Okay, and what does it mean, a streamlined shape? It's a very homogeneous shape, a minimum surface area, right? Exactly like in the sedan car or the racing cars, they are having a streamlined shape that makes the contact with air particles is very low, other than the huge cars or the big cars or the cars that are 4x4, right? Let's elaborate more through this diagram. So the first diagram on the left hand side, you can find that this shape actually have 100% resistance. Many particles are coming in front of this shape. Okay, now on the right hand side, if the shape is like a ball, you can find that less particles are in contact, okay, rather than the first one, but actually there is a contact. Now, the last shape, as you can see, the streamlined shape, in the beginning of this shape, you can find that the surface area in contact with the particles is really less or the least among all of the other shapes. So this means that the beginning of the shape is having the least contact with air particles. Okay, so this is the advantage of the streamlined shape. That's why the aeroplanes and the birds and the racing cars are all designed to have a streamlined shape, to have the minimum surface area, to have the minimum friction between the body and the particles of the air. Now, the size of the object already is mentioned. It's very similar to the concept of the shape, right? As the bigger the size, have more contact with the air particles, right? So the bigger the object or the bigger the surface area, the bigger the contact with the air particles, the bigger the air resistance. Now the speed of the object, and I have mentioned the example that if you have a certain car, okay, and you're always driving on highways or runways, as you speed up, you find that the body of the car is in more contact with air particles rather than driving slowly. So becoming more in contact more with air particles mean that you're having more air resistance. So the faster the object, the higher the air resistance. Now, which parachute do you think will fall the fastest? The bigger one or the smaller one? Okay, so yes, the smaller one is going to fall the fastest. Why? Because small parachute means small surface area, right? And small surface area means small or less air resistance, right? Now you have less resistance to your motion, so you can speed up, right? So that's why the small parachute will fall faster because it will consume less time because it has less resistance. Now, which leaf is going to fall faster? Definitely the small leaf, and the acorn will fall faster because the acorn surface area is less, so it's going to experience less air resistance. Less air resistance means less time, so it's going to fall faster. Okay, now we have already elaborated about the great journey of the skydiving, and in this journey, which is really amazing, two main forces are acting on your body. Let's take it stepwise. Okay, now first of all, you are dropping yourself from the airplane, right? So now you have your weight acting downward and you have the air resistance. But at this moment, at this stage, your weight is actually bigger. So you're going to speed up. You're going to fall down with a very high speed, okay? And your speed is going to increase by time. Okay, these forces are actually now not balanced. Why not balanced? Because the weight is bigger than the air resistance. That's why you're going to speed up while you are falling. Now, because you are speeding up, the air resistance is going to grow, okay, or to get bigger. Now, air resistance becomes equal to the weight. Since air resistance is equal to the weight, so the forces acting on you are balanced and you are falling now with a constant speed. Now, when you open the parachute, what happens? Suddenly, the air resistance is now bigger than the weight, as you can see from the arrow, right? And this time you're going to slow down. Why? Because the bigger force is lifting you upwards, which is the air resistance, and you're actually going downwards. So a slowing down is going to happen because the forces are unbalanced and air resistance is bigger than the weight. Now, because you're slowing down, actually the air resistance is going to become slower. Okay, so at this time, again, air resistance becomes equal to the gravity. And you're falling now with a constant speed. This time only you can land safely. Why? Because you're not going to rush into the ground. You're going to land with a constant speed. Right? Now let's check the graph. The graph is actually telling us the whole story. So since you're jumping from zero speed, okay, and you didn't open the parachute yet, now the gravity is bigger than the air resistance, so you accelerate. Accelerate means you're speeding up. Why do you speed up? Because the gravity is pulling you downwards more than the air pushing you upwards. So you're accelerating. Now, when you are accelerating, you are having a high speed, right? The higher the speed, the higher the air resistance. So now the air resistance starts to become equal to the weight. So now you fall with a steady speed. Now you start opening the parachute at this specific point. So once you open the parachute, high surface area means higher air resistance. Now the air resistance becomes bigger than the weight and you start to slow down, so your speed starts to decrease or you decelerate. Again, when you decelerate, the air resistance becomes lower than before. So now one more time, air resistance is equal to the gravity, right? So you fall with a steady speed or a constant speed until you reach the ground, right? Okay, thank you very much for being with me today. Please follow me in the third part of forces. Bye.